Hi, I'm Rolof, and today I'm cutting some examples on the CARVERA machine. We will be cutting some PCB boards with and without solder mask, ABS plastic, aluminium, acrylic, some laser engraving, and we'll be milling some tooling board in the 3-axis and the 4th axis. This is all the examples that comes with your machine, and these parts are already set up for you. The only thing for you to do is set up the material and open the controller software and set the parameters and offsets, and the machine will do the rest. Before you start, just check that the tools are in the right positions in the machine, and then you are ready to go. Let's go. First, let's make some PCB boards, one with solder mask and one without. For the PCB with solder mask, you will need the PCB fabrication kit, which is an optional extra. It comes with a UV lamp, solder mask roller, and 5 different solder mask tubes and an applicator. This is how I make the spoil board. I will just trace the material, give it a few scores, and break the MDF. And the same on the other side. Next, we will place this into the machine as per the example guide booklet, check the orientations and clamping positions, and then go to the controller software. Next, you open the file which is already on the machine. You can find this under Examples, LED, PCB UV Mask Part 1, and select. The reason this PCB consists of 2 files is that between Part 1 and 2 you will put on the solder mask. Here I will just scan through the toolpath to check if anything is out of place. Next, we'll set up the configurations. Let's first give our work origin an offset. The material is mounted at anchor point 1, and we will set the X offset to 15 and the Y offset to 10 mm and hit OK. Now we have some clearance between anchor point 1 and the work origin. We will activate the scan margin to check the border line and check any obstructions. We will also activate the Z probe functions and give it the offset 5 mm on X and 5 mm on Y from the path origin. In this file's case, the path origin and the work origin is the same position. Last thing to do is activate the auto leveling. Auto leveling really helps for PCB fabrication as the cutting depths need to be really accurate. We will set the clearance height to 2 mm and the X points to 5 and the Y points to 5. Hit OK and press run. When the first cut is complete, we will go to clearance. This will give us the opportunity to do some cleanup, sand down the PCB so there are no burrs or edges, and then apply the solder mask. I keep my part in position on the machine to make sure there is no movement, as this might prevent some misalignment on the next program. Try to get the solder mask evenly spread out and into all the grooves. Then we will place the UV lamp over the part and give it about 20 to 30 minutes to dry depending on the humidity in your shop, and the thickness of your mask. Now we will go to the second program and load. In the configurations, we're going to switch off the scan margin and the auto Z probe and the auto leveling, as the machine already has that configured from the previous cut. The solder mask removal tool will now remove the UV mask you just applied at 0.2mm thick, and then the corn bit will drill holes and cut out the part. When that is complete, we will remove the part, do some cleanup, and do some sanding. Now, I am no electrical engineer, but I think this PCB looks great. Next, let's do the same thing, but without the solder mask. We will mount the spoil board and the single-sided PCB board to the machine. You can also use the examples guide booklet to reference all the mounting positions. Then in the controller software, we will locate the PCB no UV mask file in the examples folder under LED and load. Now here you can see that this is a full program that cuts out the part as well. We will configure the part to the correct offset from anchor point 1, 15 on X and 10 on Y. We'll also activate the scan margin, the auto Z probe, as we have changed the material and might need to recheck the height, and also activate auto leveling due to some cases the material might be slightly bent. When this cut is complete, we will do a cleanup and just break out the part, do some sanding, and then we have another completed PCB. Next, we will set up the 20mm ABS. First, we'll cut the spoil board, then clamp into position on the machine board. One thing to check is the underside of the top clamps have different heights to suit different clamping thicknesses. For thicker clamps, we recommend using the thicker side of the bracket. Next, we will find the file under LED, ABS base, and hit OK. We will configure the X offset to 15 and the Y offset to 20 from Acrylic 1 and hit OK. We'll activate the scan margin and the Z probe. We will lower the point count on the auto level, and it does not have to be so accurate as a PCB. So we'll set this to 5 on X and 3 on Y and hit run. When that is complete, we will do a cleanup and prep the part. Here I will just use the saw provided to remove the tabs. Do some sanding, and the base is complete. Next, the acrylic. Let's prep the spoil board for this light panel and mount in the machine. You have a few design options to choose from for this part of the light. In the software, you will either find the Superman design, R2D2 design, face design, make hero design, or the balloon design. So you can choose the one you like and select. Next, we will set up the configurations. Once again, you can refer back to the booklet for reference. We'll set up the offsets to 15 on X and 25 on Y. We will activate the scan margin and also activate the auto Z probe. We will set the auto leveling to 5 on X and 5 on Y, then hit run. Once that is completed, We'll do a cleanup and prep the part. The bottom of this part is cut with a V-groove, so by just bending over this part, you can snap off the edge to create a clear edge for the light to pass. Next, aluminium. And we'll follow the same steps. Spoil board, remove protective film and mount in the machine. The spoil board does not have to be the exact size of the material, as we are only cutting a small part out of this. Make sure to clamp securely, but not to put too much pressure on the top clamps. They are made of aluminium and can bend when using too much force. Open the file under LED and aluminium button. We will go to configurations and set the offset of X to 10 and Y to 10 from anchor point 1. We will activate scan margin and also activate the auto Z probe. We will set the auto leveling points to the minimum, as this is a very small part. OK and go. Now you can just break out the part and sand off any burrs and sharp edges. Now for the laser engraver. We will measure out the 120mm by 100mm and place into the machine. This part only needs one clamp, as the laser has very little force on the material. In the controller software, go to the examples folder, the laser folder, and find the ordinary Hempern laser engrave file. Here you can see how the laser will react to cut this part. Next, let's set up the configurations. In the software, we will set up the X offset to 7.5 and the Y offset to 10. We will activate the Z probe and the scan margin. We will uncheck the auto level, as the laser engraver has a high tolerance for little difference in flatness. Reminder to use the included laser goggles when using this function. The laser can also damage camera lenses, so we recommend getting some UV protection for your lenses to prevent this. My camera is mounted on the outside of the machine on a GoPro mount, but put the lens right into the cover. The laser process does create some smoke and might fog up the inside of the machine, as you can see here. A bunch of small dots creating an art piece like this. Beautiful! Next, we will set up the tooling board for the 3-axis relief milling. First, we will prep the spoil board and set it up in the machine. And when you're ready, go to the software and find the file under the relief folder. In the configurations, we will give the part a really small offset, as this file already has a built-in offset. We will activate scan margin and also the auto Z probe. We will deactivate the auto leveling function because we want the material to be milled to a specific height. Next, we will proceed with the cut. It will first do a roughing pass and then it will proceed to the finishing pass. Here I will just use a toothbrush to clean up most of the particles between the grooves and sand off the edges to clean up the sides. Next, we will set up the 4th axis module. For more detailed information on how to set up the 4th axis, you can check out the previous tool breakdown video. You can click on the link here. We will mount the material in place with the provided wrenches, remove the dustbin and the dust foot. Next, we will go to the controller software. You'll find this file under the rotation folder, and you'll see that this also consists of 2 parts, roughing and then finishing. So we'll set up the offsets of X to 60, and the Y is already configured, and the machine knows that the 4th axis module is plugged in. We will activate the scan margin. In the 4th axis application, the scan margin is only a line that scans the X axis. And the auto Z probe is automatically updated to the 4th axis fixed point. Now this is a very messy cut due to the vacuum and dust foot not being used. It just shows you how effective the foot actually is. So here we'll do a cleanup and grab the finishing file on the software, uncheck scan margin and uncheck auto Z probe and proceed to cut. One thing that you'll notice on the finishing cut is a problem with the Gcode. The machine cuts a hole behind the one ear. Now you don't have to worry about this, and it's only an error on the Gcode file and not the machine. The first batch of these machines is going to have this error on the file, but we have rectified on future machines. Please let us know if you need the updated file. Here I will just use a toothbrush to clean all the debris and burrs, and then we can remove the material to finish off the part. Here I will just use the small saw to cut some grooves and then just break off the top and bottom. And next some sanding and the part will be complete. Last thing that we have to do is assemble your light. Now if you are interested in soldering your own PCB board, we have included all the parts to do so. To assemble the light, first prep the PCB to fit securely into the base. Find the 4 screw that comes in the bag and then prep the switch. I will use some double-sided tape to mount the button in place. Grab the PCB and fix with the 4 screws in the right orientation. Next we will find a battery source to test, and voila! And that's all the examples that comes with your machine. If you have any questions or comments, post that down below. Links to our Discord channel and other social medias in the video description. And like and subscribe to see some more CARVERA videos.